Hello and welcome to the SciShow Talk Show, the episode of SciShow where we talk about things with interesting people. We have a very special guest today. This is Derek Muller from the channel Veritasium on YouTube.
Thank you for having me.
What the heck do you do?
I make videos about all sorts of science, anything I find interesting, and sometimes I end up going on the street and just talking to people about science before I actually explain anything.
Right. You do that thing where you're like, tell me this thing, like, I'm going to ask you a question that I know you're going to get wrong, and then I'm going to shame you into learning.
Wow, well, that's not really how I look at it, Hank, but that, that could be how some people perceive it.
Whenever Derek takes his camera out and he asks a question, I'm like, oh, crap! What am I going to get wrong now?
And here, I don't even have my camera, we have your cameras.
That's true. I did turn that on you once, and I said, how long was it a million seconds ago?
How long was it a million seconds ago?
And
I did
you got it wrong.
I got it wrong, big time. There were a factor of 10 errors happening in my brain, and yeah.
So if I get something wrong, I will at least have the joy of knowing that I have previously stumped you.
You have stumped the Derek.
So what's your background?
My first degree was in engineering and physics, and my second degree was a PhD in physics education research. How to make films that actually teach science.
Yeah. Right, so you have proven that this technique that you use works.
I've shown in various research studies, I hesitate to use the word proven in any area of science, but the evidence suggests strongly that direct expository teachings, which all of us do from time to time, don't seem to be the most effective for novices, specifically. Right. So for people who don't know anything, telling them stuff doesn't seem to have that big of an impact. And there's, I think, a variety of reasons for that.
And instead, what does work?
So what seems to work is actually explicitly bringing up misconceptions and then explaining how they don't quite work and then getting to the truth, which is my goal all the time.
Walking down a path.
Yeah.
Instead of saying, here's how it is.
The really important thing is that you start where your audience is.
Right.
You don't get anywhere if you start at a level where they don't know where you're at. But you think that they know where you are. And
and then walk them through the process of how.
Yeah, take them from.
Why is it that this is wrong? In fact, you probably could figure this out on your own.
Just through a series, it helps to have someone there to guide you through.
My favorite of your videos is where does the tree come from? Like, where is
the mass
all
of
that
a tree.
mass of a tree? And people are like, it comes from the water and the soil. And in fact, if you think about that, why is there no giant hole around the tree? It must come from somewhere else. It comes from. You'll have to watch the video to find out.
Yes, you can go to my channel.
youtube.com/veritasium. So, are you going to attempt to make me feel foolish, shame me into into learning more about my world?
Let's try something. Let's just try some warm-up questions and see how we go.
Okay.
Yeah? Okay, so here's the first thing we're going to try. I'm going to give you a set of logical statements, and you're going to tell me whether these are true or false together, whether they fit together.
Terrible at logic.
Are you?
Yeah. I like flunked that section of the SAT.
Right.
Seriously.
Okay. Well, let's. I think that you can do it. I actually don't think it's. Anyway.
Okay.
We'll give it a shot. Okay. All roses are flowers. Some flowers fade quickly. Therefore, some roses fade quickly.
No, that does not make
false.
sense to me. Yeah.
It is false, and that's good because that's a false question.
Okay.
Let's try another one. A bat and a ball together cost $1.10.
Okay.
The bat cost $1 more than the ball. How much does the ball cost?
I want to say $1, but that's wrong.
What's interesting is that if you ask that question of college students, roughly 80% of them will say 10 cents.
Yeah.
That the cost of the ball should be 10 cents. Because, but immediately there's a problem there because if you think it through, if the ball is 10 cents and the bat is $1 more than the ball, then the bat would be $1.10, and then together they would be $1.20. So you can clearly see that it wouldn't work. Right. But 80% of people will quickly answer the question that way.
Yes.
The correct answer would be, of course, 5 cents, because then it all works out.
I almost said 20 cents. So that would have been going the wrong way.
Yeah, but similar idea. It's hard to do math in your head. I think that's granted. But I mean, the thing that is interesting to me is the way that we're drawn to intuitive answers, to quick answers, to things that sort of seem like they should make sense. And I think you and I, more than most people, like to think about things a little deeper. Like we don't want to just go with our gut right away because we know that can get us into trouble sometimes.
Right, especially when you have a guy on your talk show trying to stump you.
Right.
Then you know that something's up.
I'm not really trying to stump you, though. Okay. I thought you would do well with these questions. I'll try one more.
Okay.
Okay. So there are lily pads in a pond, and every day they double in area that they take up. On day 48, the whole pond is covered.
Okay.
When did they cover half the pond?
On day 47.
See, beautiful. Beautiful, Hank. That is absolutely correct. So this is where I'm saying, like, you know, an intuitive reasoner would say day 24.
Yeah.
Yeah. Forget the whole doubling thing. Like, exponential growth is a crazy thing to get your head around.
Yeah.
Okay.
You had to start with a very small lily pad, or it was a very large pond.
Yes.
To get to 48 days of doubling.
Yeah. I don't know how that would actually work. That'd be crazy to see day 47 to day 48. Would look weird. Let me ask you this question. Where do we get energy? As human beings, where do we get our energy from?
Like directly or indirectly?
Let's not go too far back down the chain.
Okay.
So let's say fairly directly, where are we getting our energy from?
From our food.
From our food. In what way? Like, what kind of food will give you energy?
Fats, proteins, or sugars,
right,
for the most part.
Okay. And if we were, say, talk about a common sugar that we get energy from would be?
Glucose would be the most common one.
And
is that what we have here?
That's what I've got for you there.
Okay.
We have a molecule of glucose. Now, I'm a physicist. I have created this. I'm hoping it's right.
Yeah, it looks, I mean, I don't know the exact structure of glucose, but you've got your alcohol sticking out here, you've got your oxygen in the ring, and then your extra little...
It basically checks out.
Yeah.
Okay, so the question is, like, where is the energy coming from?
The bonds, man.
How so? Can you elaborate? Like, that's the point I want to get to. Like, how do we get energy from bonds?
Well, we have complicated metabolic chemistry that we do on these things, and so the idea, basically, is that this is less stable than carbon dioxide and water, which is what we break it down into. So there is an energy differential between this, which was basically created by a plant, probably. It may also have been created by an animal. That wanted to store its energy, and to do that, it converted carbon dioxide and water into a much more complicated thing, and that difference in stability is energy that was pulled out of the sun to create a more complicated and less a molecule with more energy stored in its chemical bonds, and then we break that down and reverse that process, like pretty much literally reverse that process to remove the energy that plant stored, which is how life works, which is pretty awesome.
That is awesome. And I think your view of this is really nuanced, and it's great, and it's a lot better than most people on the street would say. I mean, it's this phrase where we say the energy stored in chemical bonds.
Right.
That's the thing that gives me trouble.
Okay.
Right? That's the thing that I'm concerned about. If you see a bond as an energy storing thing, I feel like that's problematic, because anytime you form a bond, what happens? If you had two things and they were separate, and you just bonded them together, what would happen to the energy?
What would happen to it?
Yeah. If you took two things, like, what is this, oxygen and hydrogen, and you just sort of stick them together. Of course, it makes more sense to stick.
Yeah, that actually wouldn't.
Sure. But we could stick another one in here. Anyway, the point is, when you bond two things together, what happens to energy of these things?
It decreases.
Right. And what happens to that energy that was there?
It is heat.
It can be heat. It's just released away from this thing. So I guess my point is that bonds are kind of a signal not of energy being there, but of energy not being there.
Right. Well, of decreased energy.
Of decreased energy.
Yeah.
So I guess the point I want to make is, a lot of people think that energy is stored in chemical bonds, when the answer is it takes energy to break chemical bonds.
It does, but it also takes energy to form them sometimes. For example, it takes energy to form something it takes energy to form glucose. If you have it, and it actually takes energy to break up glucose, you just get more energy out than you put in.
This is exactly the point. This is the crux of the matter. I guess one of my questions is, why do you consider the energy as being stored in that molecule and not stored in these molecules? Here, I've got some oxygens.
Yeah.
Why isn't
Where
the
did
energy?
those come from? Are you doing magic tricks?
Why is the energy in these bonds and not in these bonds? People think they're getting energy from glucose. They don't think I'm getting energy from oxygen.
Well, because there is energy in those bonds, but there's there is.
I just feel like it's unfair to say that there's energy in bonds. Like when you form bonds, energy is given off.
I guess it's a useful tool for understanding how energy flows, from the sun to our pancreas.
But my concern is this, right? If you think that there really is energy in bonds,
Yeah.
then you would imagine something like breaking those bonds open releases that energy,
Right.
which is totally false.
That is true.
This is my point. It's the formation of bonds that releases energy, and it's the breaking of bonds which takes energy. And if you have that clear idea about bonds, it allows you to extrapolate to all sorts of situations. Like, have you seen these videos where people grab ice cubes that are covered in salt, and they just squeeze them really hard, and it's really, really painful? Have you seen those videos?
No, that's new for me. But
Okay, this is a thing. Okay, there's tons of people out there doing like the salted ice cube challenge.
Of course there are.
And it makes your hand really cold. Like the ice cube might start out at 32 Fahrenheit. I'm doing that for you guys. Okay, it might start out like that, but then it's going to get colder. The ice cube gets colder by putting the salt on it and then squeezing it. Now, why is the ice cube getting colder?
Because I don't know,
You're breaking the bonds between the water molecules.
the hydrogen bonds.
No. Well, yes. But yes, because it's a solid thing. So you're breaking those bonds in the ice, right?
Yeah.
And that takes energy. It's actually lowering the temperature. So your hand could get down to like, I don't know, 20, 15,
Right, but
10.
I mean, if you
That's why it's
have
a real
a cube
challenge.
of sugar and you light it on fire, energy is being released.
Correct. That's because of forming bonds. It's not because of breaking bonds.
Right.
And I mean, my point again is also
Because
that
the bonds that are being formed have less energy than the bonds that before.
Exactly.
Okay.
Exactly. That's what I love. But the other thing is, like, why do you say that the energy's here and not here? Because if you didn't have any oxygen and you tried to light something on fire, it's not going to work. So the point is, the energy is just as much in these oxygen bonds that you're breathing in as it is in there. If you want to consider, energy to be in bonds in some way at all. So I feel like we just need to change our views of bonds.
But I want the energy to be in here.
I know you do.
Because that's where I get my energy.
I know you do. And so there is a way in which we can say that this has energy.
How would you say that?
Well, I would say that the energy of these bonds is less than the energy in the bonds of products you could create.
Right.
So therefore, there is more energy kind of with reference to that as your final state. So, but I guess a really important point is to think about initial states and final states. Relative to all these atoms being separate, there is less energy here. If you had all those atoms separated and you put them together, that would give you energy. You seem unconvinced, Hank.
I'm not unconvinced. I just think that it is a less useful cognitive tool. I think that it's more correct.
Okay, but I feel like we just get ourselves into trouble when we think in
Right.
terms of what you're talking about. Because, for example, in nuclear fusion, for example, in the sun, what's happening? These two nucleons are coming together, hydrogens, protons are coming together, and they're fusing with each other. So what's happening to, how do we get energy there?
Well, that's a whole different story.
Is it?
Now it's nuclear physics.
Okay, now it's nuclear physics, but the process is very similar. You're bonding things together. Why are they bonding together?
Bonding things together.
Yes, you're bonding things together.
Well, but not with chemical bonds.
Not with chemical bonds, but with nuclear bonds. Does it matter?
Yeah.
No.
It's a different.
This is my
It's a whole
point.
different mechanism.
It is a whole different mechanism, but the point of energy is the same. Things come together and they bond when they can go to a lower energy state.
Right.
And then they're releasing that energy.
Right.
I mean, there's a thing in physics that we talk about, the nuclear binding energy. This is the most, one of the most rampant misconceptions I see anywhere in physics. It's about thinking that these nucleons require energy to bind them.
Nucleon, protons.
Protons and neutrons.
Yeah.
Right. Okay. So people think that it takes energy to bind neutrons and protons, but it doesn't.
It releases energy.
It releases energy. So the point is, things are bound not
But
by
it
the
takes-
energy they have,
it takes
but by the
energy.
energy they have lost.
Right.
Do you see how beautiful that is?
It is
Things
nice.
are bound by the energy they have lost, not by the energy they have.
And the energy that they're losing is the energy that we're using.
Exactly.
It's a good stopping point.
Isn't it? Let's bring out a skunk.
You were right. We got a skunk.
Surprise! Here's a skunk.
Yeah, I'm being quiet. Don't have to be quiet.
No, she's all right. She's
super docile.
She knows you're there.
Okay.
This is the closest I've ever been to a skunk, by far.
This
Probably
is actually
a good thing.
This is actually not the closest I've ever been to a skunk.
Really?
That's frightening.
Yeah, Catherine once found one in one of the wells of around a recessed window in a house. She went in there with a shirt and rescued it.
Wow.
And,
brave.
Yeah, very brave. That's my brave wife.
Yeah.
So this is Lollipop the skunk. What kind of skunk is Lollipop?
She's a striped skunk.
Because of the stripes.
Yes, and there are different species of skunks. There's spotted skunks and there's hognose skunks as well. So this is a striped skunk, and you can see those big. Oh, she likes that.
Oh yeah, that's what my cat does.
Did those other species have stripes?
They don't. They have spots, or the hognose does, I believe. But the spotted one is smaller than this. Looks more like a weasel, and it's more splotchy, spotty. Mm-hmm. And they're smaller too.
Is this native to Montana?
This is native to Montana, native to North America, and they'll go down south a little bit to Central America as well. And she is not full grown. She's about 8 months old, and she'll get bigger than this. They can get quite big. I shouldn't say quite big. They can get, their body can get about that big.
They're sort of the size of cats.
Yeah, similar. Yeah.
But they don't look like cats.
They look kind of like a miniature badger.
Yeah, totally like a miniature badger.
Yeah, and then they have these short little legs, so they kind of walk around like a badger too.
Mm-hmm.
They almost waddle.
And those look like digging claws to me.
They are, yeah. So they use those claws not for defense or offense. They're, well, I guess offense. They're gonna dig up worms. And
Offensive against the worms, but not for attacking other mammals.
No. Well, they'll go after. They're omnivores, and they're opportunistic omnivores. You gonna go hide? Oh no, she's not hiding.
She spotted the food.
She is getting after this food here.
That was quite clever.
Oh yes.
So perfect timing.
When Lollipop came out, she was exhausted and just wanted to sleep. But then the food got opened and much more active.
And that's the two great points. She's nocturnal.
Okay.
So she would be sleeping during the day, and so that's why she was so tired. Mm-hmm. And then these guys are crazy about food. Like that's all they really care about. They want to eat and eat and eat, and they'll eat anything that resembles food.
You need those chemical bonds, the energy that is not stored in the bonds.
Now, speaking of chemical bonds, like skunks are known for obviously smelling disgusting. Mm-hmm. What is that molecule that they're spraying at you?
Oh, I'm not a chemist.
Okay, but she's not trying to spray us.
She's not trying to spray you. She's not threatened right now. And actually, they don't want to spray. That's kind of a misconception. Skunks don't go around the world, every time just spraying things, anything like a twig breaks in the forest, and they spray it. They're not going around just trying to douse everything in their stank, but
they'll do it. They will do it from time to time.
They will. They will if their life is threatened, if they feel like their life is threatened. But they're going to warn you ahead of time. All right, we're going to give you a break from eating for a second. We'll show you off a little bit more. So they're going to do these warning systems before spraying. So one of the first things that they're going to do, you should ask Catherine if this happened. First thing that they'll do is they'll stomp their feet. Mm-hmm. A lot of people aren't very observant about that, so they'll miss the stomping.
Their front feet?
Their front feet, and it's kind of funny because they have these little soft pads, and so it's almost like they're slapping the ground. They go slap, 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 slap. And then the next warning that they'll do is they'll do these little charges. Now they're not charging to, be on the offensive. They're not going to come and attack you or anything. They're going to do these charges and their head is almost down, and they're just running at you, and they'll hiss while they're doing it. They're trying to say, get away from me.
I feel like you have a very good defense mechanism. Just use it rather than trying to charge me and slap them. Just turn around and get me out of there. Like pepper spray my face.
The reason they wouldn't, there's a reason, is because they have, now this isn't exact science, but it's approximations. They have about 6 sprays before they run out of their stink. And then it takes almost a week for them to recharge. So if they're just going around spraying everything in sight, they're going to run out, and then they'll have no defenses.
Right.
So they want to, their first warning is their color, warning colors. Their second is the stomp, then is the hiss and the charge. Some will even do a handstand.
What?
That is awesome. Can we get a picture of this guy?
She doesn't do a handstand. We're working on training her, and she's never been scared enough to show off a handstand.
Yeah.
But I have seen them like put up their, like they turn away from you and they lift up their tail and stuff.
They'll lift their tail, and that's even another warning.
That's
so
getting closer
There's
to the...
one more thing they have to do. They're not just going to put their tail up and just spray. Well, if it's quick thinking, they might. But if they're really like trying to ward you off, they'll put their tail up, then they'll turn around and aim at you. They'll turn their head around, peeking around the corner and aim at you. Exactly.
Where's my butt pointing right now?
I'm gonna get you. And they can shoot up to 15 feet, and they're very accurate.
Wow.
Frightening.
I've looked up the chemicals. There's actually a webpage on the internet called the History of Skunk Stink Research, basically. But they're thiols, so they're sulfur compounds. They're organic compounds with sulfur groups on them. Sulfur bonded to hydrogen is stinky.
I can imagine.
And there's a lot of them. There's also thioacetates, which are also sulfur compounds.
So it's a bunch of different
alkaloids.
kinds of
There's a
sulfurs.
ton.
Okay.
There's a ton. There's so many. The spotted skunk has different ones than the hognose skunk, which has different ones from the striped skunk.
Wow.
I'm learning all about this.
Here, why don't you go on the table and you can eat some food? That's interesting. All those different kinds there. I do know if you are sprayed directly, like in the face, it will make your eyes burn.
Whoa! We just saw a skunk flip right here. I don't know about handstands, but she does a flip pretty well.
It's
I
very
am not
slippery. What is
supposed
this
to
thing?
be on a slippery table. I don't
This
climb.
is food, though. This is food. I'm good.
I just hang out on the ground and eat food. Sorry, Lollipop.
Oh. Well,
So if you get what?
that didn't even freak her out. Which is fine.
They're really kind of like bulldozers almost.
Skunks are very common, but you don't generally see them.
No, they're kind of secretive, so they're going to. I mean, they don't camouflage. Obviously, they want to stand out. But they mind their own business. They just go through the forest and they, rough and tumble on the understory there and just digging roots and tubers up and eating anything that they come across. So they live a solitary life and
Well, it's
they don't
interesting
really try and get in your business.
you mentioned
unless you
that-
have trash around your house.
Right.
I've seen like groups of skunks going around together, like families.
Families,
So do they hang
Mom
out
and
with their
babies.
families or only for a short period of time?
about a year, maybe. That's going to be the extent of the time. It's usually going to be even, push that off of there.
Get it.
It's usually going to be less time
Does
than
not care
that.
for glucose.
I want protein. Nice one.
Wow, she's voracious.
She will eat if we give her a bunch of food, she'll eat until she makes herself sick. Nice work. And I brought some little bugs. You can see she really
Oh, live bugs.
live
Her
bugs.
favorite.
bugs.
Okay, it's behind you. Turn
Can you
around.
smell it?
Oh, yeah. Crunch, 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 crunch,
Crunchy.
crunch.
You could tell. She really loves that
She
food.
really enjoys
So
that.
Lollipop, though she doesn't want to spray us, she also couldn't.
She is descented, and that is, it's a procedure kind of like spaying and neutering. She feels no pain now. It is surgery. But we do that because she's an educational animal, and it'd be very educational if someone were sprayed.
A little too educational.
We don't want to go down that path.
Yeah.
So that's the reason that we do it. And
And-
she was rescued from a fur farm, so she was going to be raised to be someone's scarf or hat or.
I didn't even know they did that with skunk.
Yeah, they're common. It's common. Yeah, but she gets to live out her life at Animal Wonders, eating as much food. Well, not as much as she can eat, but a lot of it.
As much as you allow her to eat.
Exactly.
She does seem like she knows you, though. Like, she comes over to you and she knows where
I
the
have
food's
food.
coming
She
from.
knows I have
But it
food.
seems like more than that, right? Like even.
We have a trust bond, and that's what we work with. If you see if I try and pick her up, she'll flatten herself. She's like, no, I don't want to be picked up. Can I pick you?
That's amazing.
Because skunks are not, they're not good at climbers or flyers, so they are just really comfortable on the ground. So if I hold her like this, she's going to cling on because she wants her feet, stabilized. So we have a trust bond and understanding of, how I'm going to treat her and how she's going to treat me. And so, with strangers, they're going to move or smell or act differently around her than I would, and that might make her nervous because she's not quite used to it.
Lollipop, I'm surprised that we haven't met you here on the show yet. I'm really glad that you got to come in and be adorable and fall off our table and eat lots of delicious food. I hope that we treated you well and that you enjoyed being on the show. Jessi, thanks for coming in, of course. You can go to Jessi's YouTube channel. It's linked in the description. And of course, Derek from Veritasium, you should check out his videos. They will make you smarter. And if you ever run into him on the street, just walk away. Thank you guys for coming on the show. And thank you for watching. If you want to keep getting smarter with us here at SciShow, you can go to youtube.com/SciShow and subscribe.